Okay, let's take a look at chapter 3. This is where it gets into the kind of the meat of the programming. Um, so this right here, we'll talk about a lot of different features. See specific with block structure, behavior of variables in blocks, basic scalar and composite data types, control structures, exceptions, bulk operations, functions, procedures and packages, transaction scope, database triggers. Those of you who have seen programming before, then some of this will be a piece of cake. But since we don't require a programming class for this, some of this we may spend a little more time on, which is okay because some of these are easier chapters over here. Um, apply a filter here. Remember our general setup on this is we got a begin and end, and then you got code here in the middle. And I'll put it over here to play with it so I don't mess that up. Notice PLSQL is a case-insensitive programming language. We saw that last time where you could mix, some uppercase and lowercase. Come in over here, begin, lowercase works just fine. So, so I'm thinking that would cause problems. But your keywords right here can be lowercase, uppercase. PLSQL is developed by modeling concepts of structured programming like C, C++, all those things you're used to. Static data typing, modularity, and exception management. Normal SQL, you cannot handle exceptions. Doesn't work, too bad. You come in next morning, you wonder why something didn't work. But with PLSQL allows us to do that. It extends the Ada programming language. Ada extends the Pascal programming language, which is why, for those used to equals here, this is a colon equals. That's what Pascal used to do. So that's why it's just kind of carried over. And single quote string delimiters. Let's see. Unlike many other programming languages, they use curly braces to define programming blocks. PLSQL. Hi, Austin. PLSQL uses keywords to define program blocks. Basic prototype for both anonymous and name block PLSQL program is shown in this figure. Again, this is what we said. We have our structure with the begin and end. And that's what we got down here. Now, if I remember right, when I took the my test off, my test 2 last time, it didn't work. So I had to put a name on there for it to get to work here. And it ends with a semicolon. If you're wondering about the slash here, in some SQL packages, the slash actually will run it. So, notice here it comes up with null to begin with, just so there's something in there. And if you don't have anything in there, it just fails. That makes sense. Every PL SQL block must contain something. Why else would you do it if you didn't? Um, we set server output last time, didn't we? Server output. Let's see if I can spell server output. I think we did on, if I remember right. See, and that just printed our name, didn't it? Well, we're here just for fun. Still worked. I guess. Boy, that's weird. I'm not used to that. Variable names can be a mix. So you can make it all uppercase here, and this can be lowercase, and it still works. I don't think I've ever seen that in any other. Yeah. Here's how you do comments: dash dash. Now we may find some of this doesn't work because again, things keep changing. I think this version of the Oracle matches the book. I think that's what I chose. Hopefully, um, they don't have this free version that we can use in the very newest version of Oracle. So we're not like on the bleeding edge there. So this program prints my name. When you put a comment in, it just documents what you're doing. And this is kind of important with more complicated items because then you can keep track of what exactly did this script do. You may know, but you leave the company. Next person comes along, they're looking at this like, well, how in the world do I change this? And so having proper documentation, proper procedures in place is vital. We used to have a person here, very sharp guy. He was our VP of IT, and so he managed the student information system, the SIS, and he wrote a lot of programs himself, and he ran them and so forth. And well, I think he left for another job or retired, one of the two, and nobody knew anything about what he did. Things weren't documented. Nobody knew how to run them. It was horrible. Students would just say, "Well, I'd like a copy of this." It's like, sorry, the person who knew that left. We hired Genzabar, the company that put the new SIS in place, because they were the people that came up with the old one, and he had customized it so much that nobody could change it. So we had to spend a lot of money hiring them to do changes, to run things, all the vital stuff. And they said if it wasn't vital, we don't want you to even ask for it. So that was a unless it was critical, then we weren't supposed to ask for anything. Well, this new VP of IT we have here is excellent. Procedures in place. If somebody were to leave, Callie wouldn't collapse at that point in terms of IT, and that's what you should be. You should not design your systems. You should not have it all set up such that it requires you being here. It makes you feel good at first. It's like, oh, they need me, and so they call you for help and so forth. But I guarantee you, first time you take a vacation and you have to come in on your vacation because something's broke, that's when you start documenting it and you're making sure that it'll run. If you go out, if you come into work tomorrow and a car runs you over and you're gone, your systems continue on without you. Now you don't want to go overboard with your documentation. Now, if you got multiple lines, you can use a slash asterisk, put whatever, and then you end it with the asterisk slash. Now they don't have to be at the beginning or end like this. You could have them all under separate lines. This is handy, such that if and you saw me for those in C earlier, you saw me leave code there so I could use it as a pattern. I wasn't doing it because I was too lazy to delete it all to begin with. So if I wanted a pattern, which is why I brought this up in the first place, so I would remember. Like I might have forgot that this needed to be a semicolon here. So that's why I brought up this example over here. But if I want to comment out of code, leave it there for pattern. I can do that, and then down below it, do that. So now I have not destroyed any of the code, and I can refer to it. Sometimes you do this in a program if you want to keep the original code, but you need to change it. But just in case your change isn't right, and you need to revert back. Then that's why you can leave it there. Now there's all kinds of version management systems in place that track versions of your software as you change it, your program. But if you don't have any of that in place, that's a good way to do it. Okay. It talks about that name blocks. You can use anonymous block programs and scripts or nested inside other name program units. You pass substitution variables to anonymous blocks along and calling them from the SQL Plus environment. I believe you can do that from the SQL developer too. I think they're wrong about that. But notice how this has the ampersand here. That's what they're talking about. It takes the value that was input and plugs it in there, substitutes it in, kind of like a parameter. What is that? An image? Why would you make that an image? Let's see what it does here. They're probably right. I shouldn't question them. I'll put line. Bracket. And input. $33. So there's that. So they're wrong. It's just not in SQL Plus. Only when calling them from the SQL Plus department. We can run it from here, and this is where you can ask for a parameter. Does that make sense? Yeah. Okay. You mean like assigning to a variable? Let's see. Except for I don't want to set equal to that because it's a string. That wouldn't work. We need to do some converting. Oh, by the way, these are concatenation. What these are. Concatenation for a string in other programming languages is usually the plus, but they're the two pipe symbols here. And this is just a string. It doesn't have to be a bracket. They're just putting brackets around it so we can see it. So you would accomplish the same thing if you had this right here. Now, let's run this. I think you will just have to refer to input, but I'm not sure. because I think this will ask for it twice. So put 33 in there, 44. So by putting it down here, it asks for it again. So your question is, how do we not have it ask again? Let's try that. It's not promising. That's better. You notice the color of it is a keyword. So I just put an E on there because the input E isn't a keyword. So let's see. Well, I didn't print that, did I? Okay. Statement ignored. Usually compile must be declared. I don't know. We'll run across it soon, but there is a way. Most of what I wrote, I'd have run in the middle of the night, so you wouldn't have somebody actually inputting the value. Let me go ahead and have you share your screen. Yeah, I haven't figured out that yet. Okay. Okay, so like if I just have this here, let's see if it actually assigned it to that variable. DE underscore test. Let me reshare it. Okay. 33, 44. See, I don't think it actually assigned it, did it? Because this 44, I'm pretty sure is what I input. Just to verify that. Nope, I lied. So 55 was what I put input. So that's how you do it. If you do it here, it's not actually being assigned anything. But if you go ahead and assign it to a variable, like that, then you can just use the variable throughout your program. So then let's based upon that idea, by the way, this is poor programming. I should never even for speed's sake do that. Left align everything. This would imply that I could get input. Now the question is if what it comes in as, if I have to do a cast to change it to a different data type. So let's come up here. I'll say num1. Don't know if this will work, but we'll see. Num2, integer. That. If I say db mass output put line, input first number, although put might be better on that. And then num1 won't equal to output line, input second number, num2 colon equal input E, Although it'd probably be better to put meaningful names there because I think it'll come up with a little dialog box. I think it says input E. So probably if I put like first underscore number, that'll probably look better. If I put second underscore number, okay. So then the question, right? I was going to reuse them, thinking, well, that's will save, you know, um, memory. But if it pops up the little dialog box with that name, then I, want to keep that in mind. Okay, so num3, which I'll go back up and reassign num2, and ddms output dot put line num3. Okay, so let's see if it does come in as a varchar or I can bring anything in. Input value for first number. So 3, 4, and it printed the value. So you can see if you've worked with other programming languages, it works pretty much the same way. And that's what you find about anything new you're learning programming wise, is you just have to learn the syntax, you know. So anyway, okay, inner value. I guess we already talked about that. Notice here, they just got they don't have the single quotes around it. They don't have the ampersand. So it's thinking that this is like an identifier of some sort, like a variable. So it doesn't know how to handle it. So book is pretty good about showing you a lot of different ways of covering that. Okay. Now in this one, assignment operator in PLSQL is a colon plus an equal sign. PLSQL string literals are delimited by single quotes. Date, numeric, and string literals are covered in chapter 4. You assign a value to a bind or session variable inside a PLSQL block by placing a colon before the bind variable name like this. Wonder what the benefit of that is. EMS output dot put line 3, 4. Let's try it again. 3, 4. I was thinking I've just declared them up here as variables in the past. I was thinking putting a colon before it, maybe you don't have to declare it, but it still tells me it has to be declared up above. So you don't have to put a colon there, as you see from the examples done here. Um, Now that will become important when we work with SQL. Colon is like a parameter you can plug in. Like here, when you put a colon in that's expecting that to come from someplace else. Actually, SQL is that way. In SQL, I don't remember if it's colon or not, but depending upon which database package you have, if you put a special character in front of it, it'll assume it's a variable, and it'll pop up with a box asking you for it. Microsoft Access has something like that. Oracle SQL Plus has something like that. Okay, so following anonymous block declares an LV input, local variable in the declaration section assigns value to the bind variable to that local variable. So again, it's bringing in the value that's been assigned to that and then assigning it to our LV input. Notice here, this is interesting. Head in the other class. Yeah. Have a good day.
Thanks, you too.
Notice here we got a concatenation, and it's concatenating a string to a variable. Now the variable's a varchar too, but this shows you that you can have your literal strings, and you can have them attached to a varchar too, concatenated together. Now here is an exception block, and this is so if we have something happen, then it handles it appropriately. So if we run this, then here's where the exception is defined. So let's see. The last block to introduce is the optional exception block. Exception blocks manage raised runtime errors, and a generic exception handler manages any raised error. Use a when block to catch an error, and use a when others block to catch any error raised in the program unit. Following program demonstrates how an exception block manages an error, such as when an identifier isn't previously declared. So it runs this DBMS output put line, and when anything goes wrong, maybe it's an input you put in, maybe it's like they said, it's not hasn't been declared. Then it'll call this down here, and all this does is simply prints the SQL error message. So this is a default. You don't have to declare this anywhere up here. This SQL error in, and it'll print what happened. Is there any questions on that first part? Okay. And I'll skip down a little bit here. Notice what it says here. Declaring a number variable without explicitly assigning the variable causes the initial value to be null. That's because the declaration block does two things. Defines a variable by giving it a name and data type, and assigns an implicit null value to the variable. So up here, I assign something to the number, and here I assign something to the number. If I didn't assign those to num1 and num2, then this would be null. You'd have a null plus a null, which would give you a null, and it just give you bizarre results. Up here, notice that it's declared as a number. I declared mine as an integer, but that's another way that you can specify it. Okay, I was wondering, I didn't see him assign a value here. This is where it doesn't print anything because we haven't assigned a value to it. But if we're assigning a value, you could do it up here where you declare it. When you have your LV sample number, you can automatically do a colon equals up here, and the default refers to it being 1. So up here you see we got a varchar 2 colon equals, and this one we have our ampersand input. This is where you would pop up and ask us what the value is, same as what this one does. Yeah, Thursdays I'm in my office from 4 o'clock to 8:30. That's my longest time. Um, Only if you call and say get online, but otherwise I won't be on for the 4.5 hours if nobody's there. But if you and call my office number, and and then because I'll be in my office, or if I've stepped away, I'll be right back, and then I can jump on Zoom. Yeah, have a good day. Okay. Um, so this just shows you. Let's see. This is the old what it was equal to, and then after we input the value in, it replaces that with James Tiberius Kirk. So when you input that in the box that pops up, it replaces that value for LV input. Um, oh, they're indicating this as an error though, because we define it as 10 characters and this is more than 10. So character string buffer too small. Um, let's see. Too exciting there. They show how to handle catching the error, such as somebody did put in James Tiberius Kirk. It would pop up and give the error message in a user-friendly way. The idea with exception handling is that you control it in a certain manner, whatever that means. It might be that you decide that you want to print an error message to the screen. It might be that you need to contact somebody, but you handle the error appropriately. This is what we're talking about: assigning the what's on the right to what's on the left. Here shows you just in SQL, not PLSQL, but just in SQL. You declare a variable, SV underscore reader, varchar2, and when this uh, when this runs, um, then it'll take this value and like this hello reader, and it'll put it into this value right here. Let's see. This probably causes an issue. Not what you'd expect anyway, because you declared it as an integer and you're assigning it to 4.67. So when you go to print it, you see how it's printing. What is it doing? No, that's not right. They got a typo there. Um, Says it doesn't trigger an exception even though the value is equivalent to double float or number data type, while the assignment target left operand variables data type is an integer. This program simply prints um, this. Now I say this has got an error here because see how they got value is and then brackets? Well, there's no value is in this put line. Um, so what this should print looks like is a bracket, and put the value in the middle. So it'll just print the 5. It will not print value is. And it's talking about here, and I alluded to this earlier where I referred to casting. Casting is where you change from one data type to another data type. And it says this happens because Oracle Database 12c and its predecessors implicitly cast the value between two data types. Um, when you did a 4.67 and assigned it to an integer, it made it a 5. Now, I meant it does the cast for us in this case. So it did the conversion. So equals check for matching. You have your greater than equal to, less than or equal to, which we'll see. Let's see, that's varchar 2. Assign a new value, print value after the assignment. Print value before. Value before probably, default probably is outer. Yep, prints outer. Now for the inner block, sets it to a new value to the variable. Print the value after the assignment. But it prints outer again. Let's see. That one's got me thinking. LV input. Varchar 2, it's a 30. Default outer. Down here, I'm print the value of that. So dbms output dot put line and LV input. Then if I change LV input to inner, dbms output dot put line LV input. Okay, so let's run that. Let's try again. Okay, that's what I thought it'd do. Oh, okay. Outer, inner. What it's saying is, now I see what they're referring to. I didn't scroll down far enough. They're saying on this that we assign this to a value inside this begin and end, and when we assign it to that variable and print it, then it's equal to that value. But then when we get to this outer one, it reverts back to its old value. Okay. And what they're talking about there's the scope of where it's where it applies at. That would imply that if I did a begin here and end here, let's see if that's true. And if I run it, no, that's still kept that same value. I'd have to look at that closer, see what you're trying to show with that. Outer, inner, so that gets set. Inner. Okay, local name blocks. Here we got let me read that. You have a choice between two name block program subroutines, functions and procedures. Functions return a value and are typically used as a right operand and right to left variable assignments. procedure is a function that don't return a value, which would be equivalent to a method in Java that returns a void data type. Notice here, this is declaring procedure, which is a local underscore named is, and then gives you this. And prints value comes down here. And that's my local end local named. Then down here in my main begin and end, I'm going to call local named. Can't highlight it, but it's line 28. So this is a procedure you can call. So let's create one of these. So I come up here after my declaration section. It tells us to put in procedure print high is. And then if we had variables declared, we would. I don't have any variables. Begin, end. I don't know if I need a semicolon there. And local name. I do need to have the name and print high. Syntax error, partially recognized rules. Let's have to start with local. Let's start with local. Yeah, let me actually, unless it's the fact that I don't have anything in here. EPMS output, put line high. Ah, there's no errors on that line. There's the fact I hadn't put any code in. We got that up there. Now down below, when you want to call it, you notice it just is the name and then semicolon. So down here, I could call print high. So now if I run this, it says 3, 4. But you notice what it did first is it printed high. So that's how you can call a procedure. Now this procedure can do a lot of different things. It might calculate something. I'll let you read that. That's talking about all the different formats of it. Doesn't look like they cover passing parameters yet. So we'll wait on that until we get to that point in the code. See, like this one's still calling local named, which is currently this. Okay, let's play on that a little bit. Got num1, num2 declared here. So we're going to call print numbers. There. And we're going to print the value of num1. And we'll print the value of num2. Okay, so get rid of this. And call them print numbers. So after I've input those two numbers in, I know how to print numbers. Run it. 3, 4. And notice it prints my value numbers 3 and 4. Well, let's write a little program now that we've seen this, where we'll calculate something. Now, keep in mind when you're working with this, go to our tables, go to my sales. See how we declare where we have decimals, number 32, comma 2, so forth. You can also come here and have these options. So you see there's a decimal, there's a float. So all these are a possibility. Looks like there's a real, assuming that's real, a real number. Usually use number and then the decimals like that. Okay, so I'm gonna come up here. I'm gonna declare a procedure for calculating mass. Is begin, end, and up here I'm gonna declare mass. Let me try real. No, let's stick with number. Number 10, comma 2. Actually, I don't want to calculate mass. I want to calculate force. What am I thinking? Force, because I know that formula. Force is equal to mass times acceleration. So force is equal to mass times acceleration. So I'm going to declare acceleration here. Number 10, 2, and I need a force. Except for a force, looks like a reserved word. The force. Number 10, 2. Okay, and get rid of this. I'll leave that there. I'll get rid of it. Bar chart to there we go. So procedural force. Maybe I ought to call it the force just to make sure. Calculate force. There we go. So then down here, I'll say the force is equal to mass times acceleration. Okay, so I'm going to ask him to input force equals mass times acceleration. So I'll ask him to input mass. And what I call it? I call it mass. That makes it handy. Using user-friendly variable names helps. I'm going to ask them to input acceleration. So I have acceleration is going to equal to, and appears like it doesn't care if I put acceleration here. Now I'm going to call calculate force. And print out the value here. So dBMS output dot put line and force. Should we put it on separate lines just to demonstrate the put again? Force was dBMS output dot put line. Remember the put writes it that stays on line. Put line writes it and goes to the next line. The force. This probably doesn't really show the power of procedures. We haven't even talked about functions yet, but if I run this, put 3 in there and 4 in there. It says force was 12 because 3 times 4 is 12. Now I made them a number 10 too, so I should be able to put decimal points in there. 3.12, 4.07. 3.12 times 4.07. Okay, I was expecting 2 decimal places. I wasn't expecting 1. But I guess the reason why is because if you round to 2 decimal places, kind of threw me for a minute. It rounds to 12.70, which is why we got 12.7. This is something you have to take into account when you're programming, and it goes back to some of your basic math. When you're multiplying a number of 2 decimal places times a number of 2 decimal places, your answer potentially is a number with 4 decimal places. And even more than that, when you take the precision into account, how big the number is, this might not be big enough. You know, if I put a number that was the largest one that I could put into here, the largest one I could put into here, then you know, this may not be the right size down here. So when you're designing a program, you have to think about those things. Now, if I run it and put in those, I should see 4 decimal places. Did I run it? Okay. Compilation error. Now that I didn't expect. Where did I screw up? Forces this, the force, coming that. I just changed that to a. Should have been fine. Let me put it back to 2. But it didn't like me to put 4 there. Maybe I need to make this bigger. Three point oh seven, 4.02. There it is. That is strange. I would have thought that 10 would have been fine. I'll have to look into that. But if you do get that, then try adjusting that to a larger number. We'll talk more about those numbers later in the precision. Now, I should mention, I'm going to put two projects out there for this, and we're not, obviously not going to finish this chapter the way it's looking. But I want you to calculate two physics formulas. So I want you to go out and go to Google, find two physics formulas. Don't use force equals mass times acceleration. I want you to declare the variables accordingly. Remember, if you're dealing with something that should have decimals, you don't want to declare them as integer. Either if they're going to have decimals, you declare them this way, or you declare them as real. For example, if I change these to real, it'll probably still work. I say probably because that threw me off. That changed the 4. Okay, so 3 point. Probably I put a bunch of decimals. It'd be fine now. Yeah, see, we got that precision there. And you might say, well, why don't just use real all the time? Well, the idea is real will handle a very small and very large number. And your goal is to use as little memory, whether that be the memory module of the whatever is running this, or in terms of storage, the secondary storage, where you store it off in a database. Why make it real huge? It's going to be a small number that you're going to store in there. By making it real huge, then you multiply that times 5 million records in your table. Again, it's overkill. You'll use a lot of space you shouldn't have. In addition, besides your initial purchase of that for your database, when you do your backups, backups will take longer to run. They'll take more space up to save it off when they don't need to. Kind of think of it this way. Yeah, you're going to go on a trip. You go down and buy some luggage. And you're going to take 2 shirts, a pair of pants, and socks and some underwear. Not very much. It fit on a little piece like this. You could get a carry-on for the airplane, or you could buy this huge piece of luggage. And you got that huge piece of luggage, and you put that in there, and it's taking up just 10% of the luggage. You didn't need that big of a piece of luggage. That's a principle behind only use what you need. Don't pick the biggest one possible. Choose a number. If you can get by with it. Now, in terms of the two projects, I don't care if you do reals or numbers. From a practical standpoint, you should just use number. And I'm about out of time. Again, it'll follow this pretty much the same idea. You'll get the variables down here in your main program. Your main program is going to call the procedure, and then the procedure up here is where you'll calculate it and print your results. We're out of time, so I guess I'll stop there. I don't think anybody's still online, but let me stop the recording, see if there's any questions.